discussing a support vector machine. First, we have to understand what is support vector machine, then only we will be able to solve the problem. Support vector machine is basically a supervised learning algorithm. It is mainly used for classification and regression. The main major idea behind a support vector machine is to find the best boundary that separates two classes. That's where we will use this support vector machine. So it's basically used for binary classification, right? So if we have only two classes, then we can divide those two classes into two different categories. For that, we need some kind of lines which should be identified by the support vectors. That is the basic idea behind a support vector machine. In a 2D plane, it is said to be a line that is going to separate two different classes, a straight line. And in 3D, it should be a plane that separates two different classes. This is the baseline of support vector machines. See, for example, if I'm going to work with the two different classes, we have x and y. You assume this is a 2D axis in which we are going to divide the points. So now I'm going to have star. These are all some data points which represents a positive line, and if I'm going to use a dash which is said to be representing the negative points, right? If this is the case, we have to find a line which can separate these two classes. See, with the star is S class, and this minus is nothing but a minus class, different class, a negative class. So I can draw a line like this, which helps me to separate this two points. Or to be very simple, let's take in this way. Alright. So now I can draw a single line which can separate this. I can also draw a line like this, or a line like this, or it may be a line like this, right? These are all certain lines which can separate the given two classes. So we have n number of lines which can separate these two classes, as I have shown you some of the lines which can be drawn to differentiate these two classes, to separate these two classes. But the question is, which line can be used as a boundary line? This is said to be a boundary line which actually separates two different classes. So we have to find the best boundary which actually separates the two different classes, the binary classes. And what may be the equation of this? As we all know, there is straight line mx plus b equals 0. This is what mathematically we will define as an equation for a straight line. As it's a support vector machine, instead of m, we will be using it as w x plus b equals 0. So which is the right term to represent a straight line that separates two different classes. And the next thing is, if I'm going to draw a margin line, so one margin line that should be drawn to the left of the boundary and the other to the right of the boundary. So this boundary can have left and right margin lines. This is said to be a margin line. This margin line can be drawn with the help of more closest data point. If it is a right side margin, see, this is more closest to the boundary line, so I can choose this as a support vector that helps me to define the boundary, that the boundary can move till here to the left side of the boundary, and this much of width can be used to move this boundary line, right, which doesn't affect the categorization or the classification process. So on the left side I have this is much closer to the boundary line, so I'm going to use this as a support vector. It doesn't mean we should have only one support vector. We can have n number of support vectors. See, this also can be used as a support vector. Alright. So I can have two support vectors on the right side, and left side I have one support vector. So like this we can have n number of support vectors. This is basically defines that this boundary line can be adjusted to this much of extent or this much of extent. Even if I'm finding minus here, a single minus point here in between this, and this can be moved. The boundary line can be moved till here in order to make this minus join here. Right? That is the concept. See, if I have star here, alright, this boundary line can be moved till here in order to make the clear separation of your positive and negative classes. And coming to the equation which can be defining the margin line, we can have it as mx plus b. Since this is a positive line, we can have it as plus 1, and the left side margin can be represented by the equation mx plus b equals minus 1. So this is how the boundary line and the margins can be drawn in support vector machine. Since we can use this the straight line to separate the classes, so this is said to be a linearly separable support vector machine. This is linearly separable support vector machine because a straight line is used in order to separate the classes. So first thing, we have to find the best boundary line, and then we have to fix the left and right margins based on the support vector, right? And the third thing is you have to find the width of this margins, both left and right margins together. What is the width that can be defined for this axis? So here we can write this width as, which is actually predefined. So the width can be written as 2 divided by the vector of the magnitude W. This is how I can write the width. I can write it more clearly. That width can be defined as 2 divided by the magnitude of the vector. This is how I can define the width of the margin lines, both left and right margins all together. What is the width that should be defined? Basically, this is how a width should be fixed. Your width, your magnitude of the vector, if it is very small, your width is large. If the magnitude of W is large, then your width is small. Alright, this is the basic thing which is mathematically proven, and we are using it in the support vector machine in order to draw the margin lines perfectly. Basically, we will always decide the width to be larger. The larger width will be fixed as the left and right margins, which helps us to clearly define the two different binary classes without any confusion. So suppose if we have the W value is 1, 1, if this is the case, then how this width can be represented? See, first we have to find the magnitude of the vector. So we have a data point 1, 1. So we take 1 square plus 1 square, it's nothing but root 2. So then how I can define this width with W? That is, we have the formula 2 divided by the magnitude of the vector. So let me take 2 divided by, we have the magnitude of the vector is root 2. So here we have 1.4. So this is how the width can be calculated for any given linearly separable model. See, in case if I have the data point, I have the positive classes and I have negative classes here, and then I have some positive classes, right, and here I have some negative. If this is some kind of the data points which defines actually two different classes. Basically we have positive and negative. This star represents positive and this minus represents a negative class. In this case we cannot use a single straight line to separate. We can use two separate lines like this, right, to separate the positive and negative classes. But this is not right, since we should use only one single boundary line in order to separate both positive and negative classes, which is actually not possible here in this case. So if this is the case, I'm going to use this kind of curve which helps me to separate both positive and negative classes. If your separating line involves any kind of curves like this, then this is said to be non-linearly separable SVM model. This is quite complicated when compared to linearly separable model, that we will learn later. As of now, we will discuss how this linearly separable model will be used in order to separate two different classes with an example. So here it is also called as, this boundary line is also called as a hyperplane. So hyperplane is nothing but a boundary line which consists of the equation Wx plus b equals 0. If a single straight line is used to separate two different classes, then it is linearly separable model. If it doesn't happens and it involves any kind of curves, then you have to choose the curve kernel in order to divide two different classes. In that case, it is said to be non-linearly separable model. So basically, a width should be larger, which helps us to clearly define two different classes. So the W can be mathematically defined as 2 divided by the magnitude of the vector. And here the left and right margins can be drawn with the help of a support vectors. The support vectors helps us to define the margin lines. The right margin is given an equation mx plus b equals plus 1, since it defines the positive line, and the left side defines the negative margin line, so it is defined as mx plus b equals minus 1. So that's all about the basic introduction of support vector machine, and the next video will be discussing about a short example which helps us to clearly understand how the support vector machine calculations will be involved in order to classify the given new sample. Thank you.